Course 1, you may remember when we were learning constant factors that what we've been doing with like 1/2 is 2/4 was more than just, finding a common denominator for a fraction. If I wanted halves to become fourths and I multiplied by a constant factor of 2, this 1/2 is 2/4 is also an example of a proportion where we set fractions equal to each other. But what's different about proportion is we will mention even something like 6/9 being in proportion with 4/6. Now, good luck saying 6 times what is 9, right? I guess you could do the 9 divided by 6 trick, but it's not going to be very even. It's not going to look very pretty. So let's talk more about what a proportion is. It's not going to always be as simple as 1/2 is 2/4, but I bet you can be just fine with them. Peaches are on sale. 3 pounds for $4, it says. The ratio is 3 to 4. You can almost see the fraction on the price sticker. 3 on top, 4 on the bottom. It shows a relationship, how the quantity and the price relate for the peaches. Since the ratio is what we call constant, it doesn't change, we can buy 6 pounds for $8. We can buy 9 pounds for $12, and so on. These amounts, these ratios, 9 pounds for $12, are equal. And you can check it. We actually see some familiar math here. 4 times 3 is 12, so 3 times 3 is 9, right? Wouldn't have been as easy with the 6 to 8 though. Actually, no, that would have been pretty easy too. So we've got a ratio here, a constant relationship. 3 is to 6 as 4 is to 8. All right? Let's take this a little further. Which ratio, which is a number over a number, it looks like basically means a fraction, but we're putting quantities related to each other. Which ratio forms a proportion with 2 over 3? Basically, which one has a constant relationship? That's what really a proportion is. Maybe I should make sure we've read that definition back on the previous page. A proportion is a true statement that 2 ratios are equal. Okay, so a true statement that 2 ratios have a constant relationship, that they are equal to each other. 2/3 is an example of a ratio, 2/3. And they're asking, what's its other ratio that will form a proportion? Does 2/4 work? I don't think so. That just looks ugly. I could try dividing 4 by 3, which I think is 0.75. No, 1 point. Let's do that again. 1 point, 33333. 1 1/3. 2 times 1 1/3 is not going to be 2. It's like a little more than 2 or something. So this doesn't work. Equivalent ratios form a proportion. So you can just reduce each one to find, 2/4 reduces to 1/2. That's not 2/3. 3/4 is already reduced. 4 over 6, aha. You can maybe tell if I divide that by 2 and bottom by 2, common factor, you end up with 2/3. It reduces back to it. And this is improper. That means that's going to actually be more than 1. So a way to solve a question like which ratio forms a proportion with, I can try to set something up here where I'm messing around with some division and constant factors like we had before, but for a proportion, why don't we just say reduce the options down if they give you an A, B, and C, and it should reduce down to that original lowest ratio. If you want to write 4 is to 6 as 6 is to 9, using numbers, 4 is to, you can just do it like with one of these, 6 as 6, remember is to, 9. That's how you read that. It's a little bit like in Shirley English when you've got word relationships. 4 is to 6 as 6 is to 9, you could write. And the fun of this too is this is another way to show a ratio, isn't it? Oops, that didn't look very good. Right? These are ratio. You can use a colon to do that. So just like Shirley English, our English class uses these to show word relationships. You can do that with number relationships. A scale factor is a number that relates corresponding sides of similar figures and corresponding terms in equivalent ratios. Like 2, the scale factor from 3/5 to 6/10. Scale factor. This seems familiar. It's the same as the concept of constant factor from a few lessons ago. You'll use the word scale factor more often. In fact, I think we even mentioned it when we were doing maps. And you had to go from, remember when we were making a map and we said 1 inch is 25, no, 1 foot, 1 inch, I was right, 1 inch was 25 feet or something like that in real life on our maps. Well, 1 is to 25. That's really what we were saying. And then we had to find out, well, what if it's actually 75 feet? Well, then how many inches? Answer would have been 3. So we did with our maps. We've done it in English. Relationships between numbers and words. They're everywhere. Example 3 says, complete this proportion. 2 is to 6 as what number is to 30? You see what that would look like? Use a letter like N to represent the unknown numerator there. So you can find a scale factor. 5 times 6 is 30. Therefore, 5 times 2 is the missing number. How could I check if that's right, they say? You could try dividing 30 by 10, and that should give you the same number as dividing 6 by 2. Both should be 3. You could try dividing 30 by 6 to get your scale factor. It should be 5, just like 10 divided by 2. Or you could try reducing these, right? 2/6 reduces to 1/3. You could reduce 10/30ths down to 1/3. These should be equal. All right, so you get to pick a ratio that forms a proportion with 5/2. 5/2 has a constant relationship with which of these? Do you remember the way we decided the easiest way to check which one was? See if you remember, or you can rewind the video. Letter B, write this proportion with digits. You can do that pretty quickly. C, and that'll be enough. A, B, and C, please.